Hyperbolic spiral. A hyperbolic spiral is a plane curve which can be described in polar coordinates by the equation r equals APH display style r equals frac var phi of a hyperbola. Because it can be generated by a circle inversion of an Archimedean spiral, it is called reciproque spiral too. Pierre Varignon first studied the curve in 1704. Later Johann Bernoulli and Roger Coates worked on the curve as well. In Cartesian coordinates, the hyperbolic spiral with the polar equation r equals APH pH 0 display style r equals frac of var phi quad var phi nec 0 can be represented in Cartesian coordinates x equals r cos ph, y equals r sin ph by x equals a cos ph y equals a sin ph 0 display style x equals a frac cos var phi q quad y equals a frac sin var phi quad var phi nec 0 rho. The hyperbola has in the RPH plane the coordinate axes as asymptotes. A hyperbolic spiral in the xy plane approaches 4pH plus, the origin as asymptotic point. For pH plus 0 the curve has an asymptotic line. See next section. From the polar equation and pH equals a r equals x2 plus itwa 1 gets a representation by an equation yx x equals tan a x 2 plus y 2 display style frac y x equals tan left frac of sqrt x 2 plus y 2 right. Geometric properties. Asymptote. Because lim pH 0 x equals a lim pH 0 cos pH equals lim pH 0 y equals a lim pH 0 sin pH equals a display style lim var phi to 0 x equals a lim var phi to 0 frac cos var phi equals inf tie q quad lim var phi to 0 y equals a lim var phi to 0 frac sin var phi equals a. The curve has an asymptote with equation y equals a. Polar slope. From vector calculus in polar coordinates one gets the formula tan equals r/r for the polar slope and its angle between the tangent of a curve and the tangent of the corresponding polar circle. For the hyperbolic spiral r equals a /ph the polar slope is tan a equals 1 ph display style tan alpha equals frac 1 var phi. Curvature. The curvature of a curve with polar equation r equals rph is k equals r 2 plus 2 r 2 r r r 2 plus r 2 3 2 backslash display style backslash kappa equals backslash frac r2 plus 2 or 2 r backslash left or 2 plus r2 backslash right backslash frac 3 2. From the equation r equals a slash ph and the derivatives r equals a slash ph2 and r equals to a slash ph3, one gets the curvature of a hyperbolic spiral. K ph equals pH 4 A pH 2 plus 1 3 2 backslash display style backslash kappa backslash var phi equals backslash frac backslash var phi 4 a backslash left backslash var phi 2 plus 1 backslash right backslash frac 3 2. Arc length. The length of the arc of a hyperbolic spiral between r phone and r pH2. pH2 can be calculated by the integral L equals pH 1 pH 2 r pH 2 plus r 2 pH d pH equals a pH 1 pH 2 1 plus pH 2 pH 2 d pH equals a 1 plus pH 2 pH plus ln pH plus 1 plus pH 2 pH 1 pH 2 backslash display style backslash begin aligned L and equals backslash and backslash var phi 1 backslash var phi 2 backslash sqrt backslash left or backslash prime backslash var phi backslash right 2 plus r2 backslash var phi backslash d backslash var phi equals backslash c dots backslash and equals a backslash and backslash var phi 1 backslash var phi 2 backslash frac backslash sqrt 1 plus backslash var phi 2 backslash var phi 2 backslash and aligned. Sector area. The area of a sector C diagram above of a hyperbolic spiral with equation r equals a slash pH is a equals 1 2 pH 1 pH 2 r pH 2 d pH equals 1 2 pH 1 pH 2 a 2 pH 2 d pH equals a2 a pH 1 a pH 2 equals a2 r pH 1 r pH 2 backslash display style backslash begin aligned and equals backslash frac 1 2 backslash int backslash var phi 1 backslash var phi 2 r backslash var phi 2 backslash d backslash var phi backslash and equals backslash frac 1 2 backslash int backslash var phi 1 backslash var phi 2 backslash frac 2 backslash var phi 2 backslash d backslash var phi backslash and equals backslash frac 2 backslash left backslash and aligned. Inversion. The inversion at the unit circle has in polar coordinates the simple description rph1/rph. The image of an Archimedean spiral r equals ph slash with a circle inversion is the hyperbolic spiral with equation r equals a slash ph. At ph equals of the two curves intersect at a fixed point on the unit circle. The osculating circle of the Archimedean spiral r equals ph slash at the origin has radius r0 equals 1 slash to a C Archimedean spiral and center 0 r0. The image of this circle is the line y equals a C circle inversion. Hence, the primage of the asymptote of the hyperbolic spiral with the inversion of the Archimedean spiral is the osculating circle of the Archimedean spiral at the origin. Example. The diagram shows an example with A equals P. Central projection of a helix. Consider the central projection from point CHERO equals 0, 0, D onto the image plane Z equals 0. This will map a point x, y, z to the point d/dzx, y. The image under this projection of the helix with parametric representation. R cos t, R sin t, ct, c, 0. Display style R cos t, R sin t, ct, quad c nec 0 is the curve dr d ct cos t sin t display style frac doctor dct cos t sin t with the polar equation R equals dr d ct display style rho equals frac doctor dct, which describes a hyperbolic spiral. For parameter t0 equals d/c, the hyperbolic spiral has a pole and the helix intersects the plane z equals d at a point v0. One can check by calculation that the image of the helix as it approaches v0 is the asymptote of the hyperbolic spiral.